Okay, so part 2 of the composition of functions. This is a second thing that you can do with the composition of functions. You can evaluate the composition of functions at a certain point. So this is when you don't really care about what the new function and what the domain of it actually is, but you kind of just want to know at a certain point what the composite of the function is. So let's go straight into an example. So given f of x and g of x, evaluate each function. I am going to go ahead and give you f of x is going to be defined as the absolute value of negative 2x. And g of x is going to be defined as x plus 1. Okay, what I want us to go ahead and do is we're going to find f of g of 3. And g of f of negative 5. So like I said, these are you evaluating a composition of functions at a certain input. So the way that you're going to do these is, again, by definition, you just need to know what these are equivalent to. So remember, this is f of g of 3. So essentially what you need to go ahead and do is you need to first find what is g of 3. And then once you get that output, you're going to input it for f. Hopefully that makes sense. If not, let's work it out. So let's first find what g of 3 is. Now, what's g of 3? Well, we know that g of x is x plus 1. So rather than writing x, I'm going to go ahead and substitute in a 3. So that would just be 3 plus 1. So what is g of 3 equal to? When you have an input of 3, what is your output in the function g? Well, it's 4. So now here, rather than writing g of 3, we know that it's equivalent to 4. I am going to go ahead and substitute in 4 there. So essentially, this is going to look like f of 4. Hopefully. Take a second. Honestly, it's just this whole idea of inputting different things into our functions rather than just like x. So now for this one, all you got to do is go ahead and just look at your function f. We know that it's the absolute value of negative 2. Rather than writing x, I'm going to go ahead and substitute in 4. So this will be the absolute value of negative 8. And remember, the absolute value, all that operation does is just take the positive version of whatever's inside the absolute value. So this is just 8. So f of g of 3 is equal to 8. Or you can also write it as f of g of 3 is equal to 8. All right, let's do the next one. G of f of negative 5. So remember, by definition, this is g of f of negative 5. So we have to first find what f of negative 5 is. F of negative 5 would be the absolute value of 2 times negative 5. Which is the absolute value of negative 10, which is equal to 10. So f of negative 5 is 10. So now with that, I'm going to go ahead and take that 10 and substitute it into g. This would be equal to 10 plus 1. So g of f of negative 5 is equal to 11. Alrighty. This is the second part to taking the composition of functions. Sometimes all they want to ask you for is evaluating it at a certain point. And really, if you just know the definition of the composition of functions, you should be good. I wish I could ask you guys right now if you need another example. I don't know if you do. I guess if you don't, you can stop watching. But if you do need it, I will give you another one. Let me add a square root into here so that we know how to simplify down square roots. So let me give you 2 different functions now. And I also don't want you to get used to just the letters f and g, so I'm going to switch it up. Let's do some h of x is equal to x squared plus 5x. And then, I don't know, give me another letter. We'll do b. b of x is going to be equal to the square root of x minus 4. Okay, and I'll just do one example for this one. I want us to go ahead and find f. Oh, no, sorry, not f. We're not using f here. H of b of 9. Okay, so again, by definition, this is h of b of 9. So what we first need to go ahead and find is b of 9. B of 9, that is us using this function right here. So that would be the square root of 9 minus 4. And the square root of 9 minus 4 is equal to the square root of 5. Now let's not, since that's not a perfect square, let's just leave it as, sorry, I don't know if that threw anyone off. I'll just put it under if that bothered you. So the square root of 5. So b of 9 is equal to the square root of 5. And like I said, since that's not a perfect square, let's just leave it in perfect form like that. So from there, I need to take this output and substitute it in here for h. So this will be h of the square root of 5. What is that equal to? Well, that'll be, now we're substituting it into this function. So this will be, and mind you here, we got to be careful. You're substituting it in 2 places. So this will be the square root of 5 squared plus 5 times the square root of 5. Hopefully I didn't lose anyone there. Again, just look back to what you are doing and you should be good. All right, now to simplify this down, the square root of 5 squared, where you could think about as your squares canceling or simplifying out, so you're left with just 5, plus here we are going to leave this in perfect form. 5 times the square root of 5 would just be 5 radical 5. So that is what h of b of 9 is equal to. 5 plus 5 square root 5. Oh my goodness, so many 5s there. All right, I hope that is clear. That's it for these notes. This is evaluating functions using the composition. All right, let me know if you have any questions.